Welcome to Transforming Energy, the NREL podcast, a podcast brought to you by the U.S. Department of Energy's National Renewable Energy Laboratory, bringing you the latest in clean energy research from the lab. It's Wednesday, March 6th. I'm Taylor Mankel.
And I'm Karen Jerriman. And today we're talking about Batman.
Woohoo! Did you say Batman? Don't tempt me here, Karen. I'll start singing that theme song again.
I dare you. No, you're not in Gotham City, listeners. I don't mean the superhero Batman. I'm talking about NREL's Batman.
So I'm guessing there's no actual real bats or fictional bats involved here.
Sadly, no bats. But there are batteries.
There we go.
You see where we're going here. In today's episode, we're talking about a battery manufacturing project, which is affectionately referred to as Batman.
All right, I got you. I'll put away the bat signal for now. Shall we jump right in?
To the Batmobile.
So, while Gotham City's Dark Knight may have an impressive collection of technological marvels, the superhero scientists at NREL also have some cutting-edge capabilities of their own.
Electric vehicles, or EVs, have been identified as the single most important technology for decarbonizing the entire transportation sector. We need EV sales to make up 35% of the global market within the next 6 years if we want to hit our net zero emissions goals by 2050.
Which means we need to advance battery technologies so that EVs can charge faster, drive farther, be more energy efficient, and be all around just as convenient or even more than traditional vehicles.
And the secret to better batteries is in their electrodes, those positively and negatively charged conductors that generate an electrical current through the movement of ions. NREL's recent battery manufacturing project, Batman, has developed a new laser patterning process to change the microstructure of battery electrode materials.
This Batman project is helping researchers unlock big improvements to electrify transportation and make big strides towards a brighter and more sustainable future.
These innovative laser-patterned cells have gone through rigorous testing in the lab. Our researchers started small and took the process all the way to a scaled-up or life-size demonstration.
In fact, they successfully processed 700 meters of electrode material, which proves that this laser approach is scalable and economically feasible for manufacturers of lithium-ion batteries.
NREL researchers are optimistic that this new process will be adopted by the industry. Fingers crossed, Batman gets out there and helps save the world, one EV battery at a time. Taylor, let's go back to summer for a minute. Do you recall noticing a change in the air?
Blue skies, hot days, cool night breezes, of course.
That's a really nice picture you've painted, but I'm actually talking about the noticeable change in air quality. Yeah, remember the wildfires in Canada that produced smoke-filled skies and wood-burnt, chemically scented air?
Yeah, those orange-tinted hazardous skies are not the summer I was daydreaming of, but yes, how could we forget? Unhealthy air quality plagued much of the country during our hottest months. At times last summer, news sources reported that U.S. cities Chicago and New York had the worst air quality in the world.
Yeah, I remember that. And get this, air pollution, not just from wildfires, but other sources like combustion from generating energy, is responsible for more than 4 million deaths per year around the world.
Wow.
And as the climate changes, we're likely to experience more harmful impacts from worsened air quality.
We have some researchers at NREL who hope to help change that, and one of them is Garvin Heath.
A lot of the air pollution is caused by combustion, and combustion is mostly used in the energy system. So as we think about exchanging renewables for conventional, especially fossil energy, we're then clearing the skies. We're going to be able to decrease emissions and therefore decrease health effects that result from them. One of the primary motivations for doing air quality research at NREL, which is not maybe a laboratory that one would normally think about this kind of research being done at, is that it is able to quantify the co-benefits from introduction of decarbonization strategies and renewable energy integration.
Like Heath said, air quality research at NREL centers around quantifying the benefits of renewable energy and decarbonization strategies on public health outcomes. Understanding the air quality impacts on public health is key to evaluating policy interventions and prioritizing paths to pollution reduction.
This makes me think back to LA 100, the Los Angeles 100% Renewable Energy Study. NREL researchers looked at changing out power plants that are currently burning natural gas for solar and wind energy sources, bringing in electric vehicles, and trading in gas-powered hot water heaters for heat pumps.
So in total, we had a simulated reduction in PM2.5, that's fine particulate matter, and ozone, air pollutant concentrations, equivalent to around 2 decades worth of Los Angeles's effort to try to reduce air pollution from all sources within the city.
Right. Okay, taking that a step further, a big part of quantifying public health impacts of pollutants is also understanding how different communities are impacted in different ways. There's a lot of disparity.
When air quality is bad, people know it. They can see it, they can smell it, they can feel it. It has effects on their health. We have different demographic groups that are experiencing air pollution in different ways than others. Certainly, people of color, lower income have been shown in studies to experience higher degrees of air pollution and health-related effects from those than their white counterparts.
Heath and NREL air quality researchers develop and use air quality analysis tools to help decision makers design decarbonization plans that not only improve public health, but do so equitably.
Very important. Take, for example, heavy-duty trucks in Los Angeles. They travel mostly on major roads like highways, near places where many disadvantaged communities are located. The LA 100 Equity Strategies, which is a follow-up to the LA 100 study, found that by electrifying those trucks, Los Angeles could reduce air pollutant emissions and concentrations in these areas, and that in turn could help reduce air quality-related health disparities.
That's the goal, an equitable clean energy transition and a big breath of fresh air for everyone. To wrap up the episode, let's talk about a paper NREL recently released that shares recommendations for a reliable path forward as the renewable energy tech industry continues to develop.
Yeah, as renewable energy plays more and more of a role in our planet's future, it's more and more important that renewable technologies perform well.
Right.
And part of that involves figuring out what to do about degradation of technology.
Any technology is going to degrade over time. Just think of your phones and computers after a few years. They start to slow down, lose battery a little quicker, and just not function as well as when they were new. And eventually, you're itching to upgrade to something new.
Yep. But mitigating this and keeping clean technologies working as long as possible is important for national energy security and economic health.
And it could save us billions of dollars. That's billions with a B, Karen.
Ooh, that's a lot. And so this paper pointed out the ways that we can lower degradation rates for the continuing rollout of clean technologies. The recommendation in the paper came from a year of meetings between NREL researchers that culminated in a workshop that NREL organized.
The 2-day workshop gathered more than 50 scientific minds from industry, universities, and national laboratories. Together, they looked at similarities across clean technologies, identified areas they can work together, and outlined a path forward.
For instance, even though solar, wind, batteries, and electrolyzers are at various stages of development, they all share the same challenge: a lack of sufficient, accessible, complete, and accurate data.
Right. So part of what the workshop participants really urged to fix that is strengthening the relationships between manufacturers, research and evaluation laboratories, and field tests.
And that starts with data unreliability. Right now, manufacturers don't really have incentive to publicize this information. And earlier stage research often does not reach the step where reliability is tested. National laboratories and international research institutions can play a role here by distilling and de-risking proprietary data for public knowledge.
The importance of all these recommendations? That as we continue to rely on renewable energy sources for electricity, and the White House continues to pursue a net zero carbon emission economy by 2050, we're laying the foundations for renewable energy success. Thanks for joining us on this week's episode. We'll be back in 2 weeks with more news from NREL.
And if you like what you're hearing, please give us a shout. We love hearing from you and might even read some of that feedback on our podcast someday soon.
Absolutely. Reach out to us at podcast@nrel.gov. This is Transforming Energy, the NREL podcast. Enjoy the rest of your week, everyone. This episode was adapted from NREL news articles from February 2024, written by Rebecca Martineau, Justin Doherty, and Wayne Hicks. The theme music is written and performed by Ted Vaca, and episode music by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC. This podcast is produced by NREL's Communications Office and recorded at the National Renewable Energy Laboratory in Colorado. We express our gratitude and acknowledge that the land we are on is the traditional and ancestral homelands of the Arapaho, Cheyenne, and Ute peoples. We recognize and pay respect to the indigenous peoples of our past, present, and future, and are grateful to those who have been and continue to be stewards of this land.